So let us do some problems today. Okay. So the first problem is, what is the solid angle subtended by the moon at any point on the earth? I think so. Any point of the earth, given the diameter of the moon is 3474 kilometer and its distance from the earth is 3.84 into 10 to the power of 8 meters. So these are the two values given. So first let us understand what the question is. So what they have said is, you have to basically, what given is earth and the moon. Okay. So let me draw. So let this be the earth. Okay. And let this be the moon. What they are given? The diameter of the moon is, that means this diameter. Okay, so this diameter is how much? 3474 kilometer. Oh, sorry, 74 kilometer. Okay, and its distance from the earth is, I mean, any point on the earth. So let us take this is the point. Okay, so this distance, oops, what they are saying, so this is the distance. So this is how much? 3.84 into 10 to the power of 8 meter. Okay. So and what is asked is, what is the solid angle subtended by the moon from the earth? Okay. So that is, this is the solid angle. And oops. So this is the solid angle subtended by the moon. So the moon is far away. First assumption we are going to make is, so the moon is so far. Am I right? So this length, will there be very different from, so all these lines can be almost be equal. Correct? You can always consider this as a circle. You draw it as a circle. Okay, so then this distance also will be almost equal to the same distance, right? So this will be 3.84 into 10 to the power of 8 meter. Okay, and this distance is given by this. So what you want to find out, this is the solid angle you want to find out, omega. Okay, so what is the solid angle formula? You remember last time what we saw is, so if I give any arc, sorry, okay, and if this is a theta, and if this is r, and if it is d, so what is the theta? Theta equal to
d by r.
Correct? Correct, because that's the angle in radians. Correct? So yeah, when d is equal to r, when the length is equal to r, it becomes 1. That's what you have 1 radian. Correct? This is a radian angle. This is the way we define the radian. And so this is for a 2D. In a paper I draw. In a 3 dimension, this angle is not going to be only on 2, it's going to be a solid angle. That's what they call a solid angle, 3-dimension angle. So you have to take a basically 3-dimension analogy of this definition. So a 3-dimension angle will be what? In the place of d, it is going to be area. Okay, area divided by r will be r square. Correct? Because r square, because then only you become dimensionless. Okay. So this is a solid angle. So this is what they have asked. So now, so this is going to have an area, and all I have to find out is the area made by this circle, okay, divided by the distance square. That's the answer of the problem. That's the answer, correct? So why you are not able to do this? Huh? Okay, so the area subtended by the moon, okay, by the moon, equal to what? So this is pi r square, what they given is a diameter, am I right? So that will be what? Huh? 1 by 4 times pi d square, am I right? because radius is equal to d by 2, so this will be pi d square. So that's equal to 1 by 4 into pi is what the value of pi we will use? Let us use 3.14. 3.14. Wait, let us have it. Let us do it out this one. Okay, 22 by 7 will probably solve the problem. No. Okay, so 3.14 into d square. D is how much?
3,400.
3,474 kilometers square. Correct? But remember, this is given in meters, so we have to use the same unit. So let us convert this into meter units. So this will be what? 1 by 4 into 3.14 into, so this will be how much, how many meters? 1000, correct? So 3474000 meter square, correct? So that is equal to, that I can write it as 1 by 4 into 3.14 into this I can write it as 3.474 into 10 to the power of 1, 2, 3, 4, 6 meter square, correct? So this will be how much? Tell me. So 1 by 4 into 3.14 into, so 3.474 whole square into 10 to the power of 6 whole square is 12. Correct? This will be meter square is the area. So how much is this? 3.14 into 3.474 square divided by 4 equal to how much? 9.474 into 10 to the power of 12 meter square. Okay, anyway you have to check it later on. You can't use a calculator in your exam. So this is the area A. So now the solid angle is what? Area is equal, solid angle will be equal to, solid angle is area divided by r square. R they are given, right? R equal to how much? 3.84 into 10 to the power of 8 meter. So area is equal to 9.474 into 10 to the power of 12 divided by this square, correct? So it is 3.84 square into 10 to the power of 8 square. That will become 10 to the power of 16. So now how much this will be? 3.84 square is how much? 3.84 square is 14.75. Okay, so this will be 14.75. Just write it as 14.75. So when I divide that, what will you get? So 9.474 divided by 14.75 equal to, I have done some mistake, I think so. So there they are getting, so we are getting here 0.642 into 10 to the power of how much? Minus 4, correct? Minus 4 steradian. That's the formula. You remember that's the unit of solid angle, steradian. So, okay. So this should. So if you remember in the last class, last class, we discussed about the large distances, right? So there are method we saw. One method is the parallax method, by which you find the distance. Okay. So what happens when you have a large distances? Normally they use a different units, not the meter and all. Okay. So it's better to know the units. So one is first one simple unit. One important astronomical unit is, what the name itself is, one astronomical unit. The symbol is AU. Okay, and this is 1.496 into 10 to the power of 11 meter. Okay, so what is this unit is? So it's something what they have. Suppose you have the sun. Okay, so and this is suppose you assume the orbit of the earth around the sun. Okay, it's an elliptical orbit and sun is in one of its foci. So we will typically will assume. So this distance is keep going to be changing, right? For every, as it moves around, the distance is going to change, different distance. Okay, so you can always find the average distance. The average distance between the sun and the earth. Okay, so this distance is called as your what? One astronomical unit. What is that? Average distance.
Between the sun and
Yeah, distance between sun and earth. Okay, so this is your astronomical unit. Okay. So exactly this means center of the earth and center of the sun. Okay, you have to write it. And the second unit is light year, that you know, correct? What should be the 1 light year? What is the 1 light year?
distance traveled by light in a year.
Yeah, so distance traveled by light in a year, how much is the value of it? So 1 light year equal to, tell me, 9.46. How do you remember that?
I remembered part of it.
Into 10 to the power of
Uh,
15. Yeah, I know in centimeter it's 10 to the power of 18. Okay, 1 light year. That's the distance, simple. The distance traveled by the light in a 1 year. Okay, that's the distance. And there's another very important unit. So that is 1 parsec. This is the unit we normally use, 3.08. Yeah, 3.08 into 10 to the power of 15 meter. This is very close to your, sorry, this is 10 to the power 16 meter. Yeah. 16 meter. Yeah. Okay. So, so what is this parsec distances? Okay, that's very interesting. So, suppose if you remember what is astronomical unit? So, if this is the astronomical unit, right? So, this is the sun. So, this is your AU, correct? 1 astronomical unit. Okay, so you take a distant star, take some distant star, okay, and so this is the just exactly above the sun, okay, and this star, when the earth is here, this star makes sense. This is the parallax, if you remember the two-side parallax. So, and this is the position. So, the distance, let me call it as d, when your angle subtended will be 1 arc second. Arc second symbol is this. You got it? So, when your angle subtended is 1 arc second, then you call this distance is your, sorry, is your 1 parsec. Okay, so these are all simple definitions only. You can actually, find out the relation between, from here itself, how much 1 astronomical unit and 1 parsec, how they are all connected. Just find out in video. Okay, so this is the way your distance, large distance are calculated. So you may have to sometimes remember these numbers. Okay, because sometimes, usually in the questions, they will give these values. If they are not given the values, then you should know what the values is. Okay. Do this problem. A star is at 5.5 light year away from the earth. How much parallax in arc second will it subtend when viewed from the opposite points along the orbit of the earth? What it says is, so you are having a star which is typically 5.5 light year away from the earth. So it's quite far away. Okay. So, and so let me, and we are having And how much parallax noise will obtain when the opposite point along the orbit of the Earth? Let this be the orbit of the Earth. Okay, parallax means what? If you remember, there's an angle, right? When I view from here and here, you remember I said when I view from this left eye and when I view from the right eye. So there's a difference. So when it is a sun orbit, there's two positions. Okay, so this angle, what is going to make, that's a parallax. Okay, so what it says, so there are two, the sun is at the two edges. Okay, so the earth is in two opposite points along the orbit of along its orbit, right? Orbit, on the orbit of the earth, correct. Okay, so what he says is, and this distance typically, so see, we can assume all of this distance is far away. Okay, I can consider all the length to be equal because it's very long distances. Okay, so this distance is given as how much? This is 5.5 light year. Can you understand what I am saying? So what will be this distance? Tell me.
1
Yeah, this is 1 AU. So and what will be this distance? 1 AU. So what will be the total distance? 2 AU. And what is this distance? 5 light year. What they are asking? What is this angle? Can't you find? You can find or not? What is the formula? So let us, if you remember, the formula is this. If you have the angle theta, okay, and if this is D and if this is R, so what will be theta?
D. Theta will be D by R.
D by R. That's what they are asking. What is the so now what happens? So right, the parallax equal to D by R, that is 2 AU divided by R is 5.5 light year. Okay, first thing is we have to convert them into same units, right? So what is the 1 AU unit? So if you remember earlier I said 1 AU is equal to 1.496 into 10 to the power of 11 meter. Okay, similarly 1 light year equal to, tell me, 9.46 to 10 to the power of 15 meter. Substitute that. So this is equal to 2 into 1.496 into 10 to the power of 11 divided by 5.5 into, what is that? 9.46 to 10 to the power of 15. So these both are meter, we can actually do the divisions, right? So this will go divide and this becomes 10 to the power of 4. Okay, so that goes as 10 to the power of minus 4. And see, there's a way how you can divide is 2, right? So if you can divide 2, this becomes 2.75. Okay, so and then actually you can always round it off to this one, you can get approximate number. Okay, so here we will use a calculator, but we can always do that with an. So 1.496 in your exam you can't use calculator. Okay, so you have to keep practicing it and we'll do it fast. Divided by 9.46, that's equal to, yeah. So what we are having is 0.0575 into 10 to the power of minus 4. Okay, so this is what will be the unit? Tell me. What we have used? Theta equal to D by R. This unit will be what?
Okay.
This is in radian. Remember that. This is what? Radian. Okay. So this we can take it. Now this we can write as 5.75 into 10 to the power of minus 6 radian. Am I right? And like that. So then we want to convert it in arc seconds. So first radian to degree we have to convert. So how will you convert radian to degrees? 5.75 into 10 to the power of minus 6. 1 radian equal to how many degrees?
Pi by 180.
Correct. Into pi 180 by pi. You are putting reverse. 180 divided by pi degree. Okay. So, and if I want to convert it into minutes, into 60. Am I right? If I want to convert it into seconds, into 60. Do all this multiplication, you will get the answer. That's it. So, how much? So, let us try to do it. 5.75 into 180 into 3600 equal to, yes, divided by 3. That will be equal to, so what you are having, 1242000 into 10 to the power of minus 6 arc second. Correct? So what this will be? 1.242 arc second. That should be the, okay. So there's a mistake. This calculation, multiplication is wrong. Okay. What you will get is 5.75 into 180 into 60 into 60 equal to 3726 3000 divided by pi 3.14. That will be equal to, yeah, this number was wrong. So what we are getting is 1186624.2 into 10 to the power into 10 to the power of minus 6, right? So this will be equal to what? The arc seconds. So 10 to the power of minus 6 is upon 10 to the power of 6, correct? I can write it like this. Am I right? So that makes it 6 zeros, correct? 1 divided by 1, 2, 3, 4, 5, 6. So when I do it, so it becomes 1.18667 arc seconds. Okay, so there are one more thing. Do you know in your book? So do you know means you should know. Okay, small distance are measured in the units of Fermi. Okay, what is that? Is 1 Fermi. 1 Fermi distance, Fermi meter. Okay, that's equal to 10 to the power of minus 15 meter. Okay, and this is very interesting. These are basically nuclear sizes. When you go into nuclear atomic sizes and all, it goes into Fermi goes in nuclear sizes. Okay, so this is a very small unit. Okay, and there's another one unit which they use in when you use for the light and all. I said light is a wave. Am I right? So the wavelength is there. Okay, the wavelengths are very short. That unit is angstrom. Angstrom equal to 10 to the power of minus 10 meter. So which is smaller? Fermi is smaller. Okay. So this is something very so to see a smaller and smaller object. See, to see anything you need light. Am I right? So the point is, if see all your table, desk, whatever, board and everything, are they the size of angstrom? They are very big. Okay, so the light wavelength typically goes as angstrom, 4000 angstrom. They you know that. See, it goes from the visible light. The wavelength of the visible light will go typically from 4000 to 7000 angstrom. Okay, so the 4000 means what? That is 4 into 10 to the power of minus 7 meter. That is still very small compared to, so those lights you are able to see. One of the thing is, as I keep becoming smaller and smaller and smaller, when I want to see when I shoot through the microscope or whenever I am going to see, as the size of the object becomes smaller and smaller, the moment the size becomes comparable with its wavelength. Beyond that, that light will not be sufficient for you to see the smaller object. microscopes. Okay, so the microscope, you normally, what are biological microscopes? They all are not to the order of angstrom, because you're going to see the microorganisms and all. They are slightly bigger, maybe in micrometer or whatever it is. So they can be actually visible from your visible light. As you go smaller and smaller, then you have to read a very much smaller wavelength. Okay, so then it goes into X-rays. Then it goes into gamma rays. They all have a very smaller wavelength. Okay, now when you want to go into the power of minus 15 meter, so that is very, very small. Okay, so then it has written in the next class, 12th, you will study there will be a wave associated with all the with the electron, the particles and all. Okay, so then when you accelerate electron, increase the energy of the electron, its associated wavelength becomes smaller and smaller and smaller. So that was the principle used in your electron microscope. Okay, you have a very high energetic electron, so its wavelength will become very smaller. Then you can see much smaller than what you can see through the visible light or the X-rays and all. Okay, so this is what the small thing they given in your book. Okay, you can read it later on. Let us do this question, this problem. The moon is at a distance of 3.84 10 to the power of 8 meter from the earth. If viewed from two diametrically opposite points on the earth, the angle subtended at the moon is 1 degree 54 minutes. What is the diameter of the earth? This is a very interesting problem. Okay, what it says is you are on earth. Okay, and no, I should rather put it like okay, yeah. Okay, so what I want to say, so you are like yeah, so you are on earth. Okay, and so this is the moon. Okay, so what it says is when you are looking, when you are looking at from the two edges of the earth, okay, so what it makes, the angle what made is how much? 1 degree 54 minutes. What you want to find out is the diameter of the earth, and this distance is given, correct? What is the distance? 3.84 into 10 to the power of 8 meter. Is it tough? It's very simple, na? The same formula, right? So what is the formula? What you have? So the formula is what? So D is equal to distance, yeah, R theta. Okay, remember theta in what? Radian, but they are not given in radian. Remember that. So we have to convert it into radian. So R is given. R is what? 3.84 into 10 to the power of 8, and theta is equal to 1. Okay, let us first convert it into okay, let us convert the theta into the radian properly. Okay, so what they given, theta is equal to 1 degree 54 arc seconds, correct? So this will be what? 1 degree plus 54 by 60 degree. You remember that? This is what we have to do it, right? So what will be this one? Tell me. 54 by 60? 0.9. Okay. So this will be how much? 1.9 degree. Correct? Yeah, this is 9 by 10, of course. Divided by 6, nah? 0.9 degree. So now you have to convert it into radian. So 1.9 into pi by 180. So this is the radian measure. Okay, so this will be what? So this will become 1.9 into pi by 180. So this will be the diameter of the earth. Am I right? So how much will be the diameter of the earth? Tell me. So how much? 1.9 into pi equals divided by 180. Okay, so that into 3.84. Oops, I cancelled everything. Tell me what it will be. Can you do it by normal division itself? Yeah, you can do it. Okay, fine. 3.84 into 1.9 into 3.14 divided by 180 equal to 0.1272 into 10 to the power of 8 meter. Okay, so that is the diameter. So, or if I want to write it in 10 to the power of 6, I can write 12.72 into 10 to the power of 6 meter. Let us do this problem. A calorie is a unit of heat. Heat is a form of energy. Okay, so energy, I said energy unit is joule. If you remember in the last class we discussed, right? Joule is a unit of energy in SI units. In CGS units, it will become erg. So we show how to get the conversion between joule and erg. Okay, it's basically the same problem. So calorie is another unit of energy, where the heat is usually measured in calorie. Okay, so that's why you have to go for gym when you become fat, how much calories you burn. Okay, so a calorie is a unit of heat and it equals 4.2 joules. That means what? 1 calorie is equal to 4.2 joules. Where joule is, yes, there is a data, where joule is equal to kg meter square per second square. This is MK unit, right? Meter, kilogram and second. MK system or SI units. A distant civilization employs, if you remember I was saying something about alien, so they don't want to use the word alien, they are having some distant civilization. A distant civilization employs a system of units which is, they are using different units in which the units of mass, length and time. They have a measurement of unit of mass, length and time, which is, when I convert them back into our SI system, their unit of mass is alpha kg. So alpha kilogram is their 1 unit of mass. And similarly, beta meter is a 1 unit of distance. And gamma second is a 1 unit of time. So they are not using the unit as kilogram, mass and second, rather they are using alpha kilogram. This much of weight is their 1 unit. Okay, and this much of weight is there, distance is there 1 unit of distance, and this much of time is a 1 unit of time. Okay, so they are using these units and they are given. So this is the way, by this number, this is the way those units are connected. So their measurement of mass, length and time, how it is connected to our SI system is this way. Okay, so their unit is alpha kg, length is beta meter and time is gamma second. And they use these units, correct? So they also have measurement of energy based on units. So they measure energy as say something like J prime is the unit of the energy. So it is not the joules, some other J prime. Okay, so what will be the magnitude of calorie in their units? So you got the question? That means if 1 calorie, when you say 1 calorie of heat, that means it's equal to 4.2 joules in a SI system when you call, what will be that civilization in their units called 1 calorie of heat. Can you do this problem? Is it tough? Oh, I said no dimension. Okay, dimension analysis. How will you do it?
Relation with the...
Yeah, the dimension, just said, that's why already they given the dimension. In fact, they won't give you the dimension. In this question, there's no need, you should know what the dimension of energy. If you don't remember, you use any energy. You use potential energy, mgh. You find out a dimension, it will come out like this. Okay, so all energy will have the same dimension. Okay, even though if they are not given this, you can actually get it from the dimension analysis. Fine, so what they given is, given 1 calorie is equal to 4.2 joules. Correct? So now, so basically if I am able to, so 1 calorie is 4.2 joules. So joule is the unit of energy in my SI units. if I able to get a relation between this joule and this J prime, so then all I have to do is replace this J with a J prime, that's what the caloric unit. Am I right? That's all we have to do. So first we have to write out, so that so what we have to write is correct. So we have to write the, so let us write 1 joule be equal to x joule prime. You remember what we have done, correct? So x is equal to j by j prime. So what is the dimension of LMT, right? And bottom also LMT. You remember last time we did this, right? So for joule, what is the one? Length will be what? 2. Mass will be 1 and time will be minus 2. 2, 1, minus 2. Okay. So, and here in SI units, this is, okay, SI units, this is will be in anyway, they given already. SI units will be what? This will be, I made a wrong? Oh no, yeah, kg meter square is minus 2. Okay, divided by, so it is their unit, J prime, na? So their unit of kg is how much? Kg is alpha kg, L square, correct? So no, let us write it this way. Then only we will be able to get it clear. Okay, so let us write SI units. What happened? We have, this will be, length is what? Meter square, correct? So meter square into mass is in kilogram into time is in second minus 2. So similarly for them, length is how much? Beta, correct? Square, yeah, beta square meter square into mass. Mass is how much? Kg, alpha kg. Alpha kg into times minus 2, right? Time is gamma power minus 2, second power minus 2. Am I right? So let me take all these factors outside. So what we have, gamma power minus 2, I can take it above. It becomes gamma square, correct? So we are going to have gamma square divided by beta square and alpha, and rest will be meter square kg second minus 2, bottom also meter square kg second minus 2. This goes off, so this is your x. So therefore 1 joule is equal to gamma square beta square alpha times joule prime. Okay, so then therefore we have 1 calorie is equal to 4.2 joule. So this will be 4.2 times into this many times, right? So gamma square, or I can straight away write it like 4.2 gamma square divided by alpha beta square joule prime. Okay, so the 1 calorie is measured as, this is the magnitude of 1 calorie in their units.